I seen a thing on the internet on YouTube where you could, guy was recharging alkaline batteries, and so I took this one and I'm going to do some tests with it. So basically, it wouldn't power this WireMap Pro Scanner that I have here before. It wouldn't even turn it on. And so I took it and I threw it in a charger like this, which is actually a Radio Shack rechargeable battery charger. So it's got a couple bays that you could put 9-volt batteries in, and so I threw it in there. And the charge that I got on it, when I started with the battery, it was only showing 8.5 volts. So I charged it up a little bit and let it sit, and I got it to 9.4 volts before I hooked it up to my to this Pro Scanner, and wanted to get a just record the output on it. So like I said, I hooked it up in series to looks like we're getting 38.5 milliamps, and so I've got it logging to a program that I wrote a few weeks back for the UT61E, just basically a little Perl script, and so I added a timestamp to this version. And by the way, this is on GitHub if you guys are interested in that program. It's basically UT61 serial, and this with the option to log and the device that you're hooked up to, which I come out with a USB to serial adapter, and hook it up like that to the computer. And I run Linux, so I couldn't just use the Windows program, and there is another one called SIGROC. So right now we're 17:35, and let's see what time I started this at 16:35, so it's been running for an hour now on powering this, and I've got it set in the signal tone mode, so it would continuously draw power without having to hook anything up. And basically, looks like the current has stayed pretty solid. So like I said, this is a 1604. It's hard to read it. There we go. MN 1604 6LR61, and looked it up on good old Wikipedia, and basically it shows the typical capacity is 550 milliamp henries for this alkaline 9-volt battery. So just doing the math. So basically what we got is just a 9-volt battery across their load. Just do a little math on it. 9-volt, the resistance is going to be equal to the voltage divided by the current, which it started with 9.4 volts. I don't know if that's what it is now, but it's drawn a consistent 38.5 milliamps the whole time it's been running. So basically that looks like 244 ohms. But to just kind of see how long this thing should last, the specs on it said that it's a 550 milliamp Henry battery. So the runtime on it will be equal to the 550 divided by the current draw on the device or on the battery. So basically the runtime is going to be should be 14.3, and I've looked around, a lot of people say, well, you're never gonna get 14.3. That's just theoretical. So 25% of the 14.3 will give you 10.7, and this is hours. Equals the actual runtime is what you should get out of a brand spanking new battery, roughly. I mean, if you get 10 hours continuous out of that battery, that would be very good from my experience. But I have never had that wire map device run a tone generator for that long at all. So we'll let this run, see how long it runs on this battery that was dead and was put into a charger and recharged. It would not power this before. It is powering it now. Now I have another couple batteries. Here's old Energizer. It would power this device, but there's a couple others that it wouldn't. Then I get a real, looks like a real cheap battery. And I don't know, I could be wrong. It may be a good battery, but I found this outside, and the weather was around 30 something degrees. So I brought it in here. When I first measured it, it had 8 volts on it, but again, it wouldn't power anything. So I've thrown this one in the charger, and let's take it out and see. It's been in here for over 2 hours. So what I've noticed with these is when you pull them out of the charger, they're a little warm. But other than that, I'll show you something that I've noticed. Well, we've got our meter going. I don't really have a way to test the voltage right now because I don't want to stop this. Anyway, I'm going to look the specs up on this, see how long it runs, and we'll throw this back in the charger. Let me get the specs on it first. So, just a few minutes after I paused the recording, my scanner went down, and the battery's still hooked up, and it will come on for a second. Okay, so I turn it back on. Just a second ago it died immediately. The first thing I noticed is that the amperage dropped from 38.5. Now you can see it's down to 32, 31. Keeps dropping. What's interesting is a second ago, there it goes, it just died again. So looks like if you let it sit off, it kind of rejuvenates the battery a little bit. And I'm really just kind of wanting to learn about batteries and figure out what all they do. And I went looking for this one, and I did find out that it is a carbon zinc battery, which what I thought was interesting is there's a carbon rod in this battery, and even on the side it says warning, do not recharge or use it with other batteries. So I could not find anything as far as how many milliamp henries this battery has, but I did find this little document that is just a material safety data sheet, and it pretty much shows everything that this battery is made up of. So 16.9% water, 33% electrolyte manganese dioxide, and then it's 9% zinc, of course, as you guys can see. But anyway, what I also found that was interesting is this discharge time, 180 ohms at 8 hours. I don't know what that equates to as far as amp henry ratings, but I will be checking that out. And let me hook this up and see what kind of voltage I got on it after we charge it for 2 hours. Okay, so I got it hooked up. When I first started it, it had 8 volts when I first found it. After sitting in a charger for 2 hours, it's up to 10 volts, 10.083. Just curious, okay, so it dropped to 2, dropped to 1, 7.9. So I mean, it's ever so slightly dropping. And this is what I noticed yesterday while I was charging these batteries, is that just as soon as I took it off the charger, it would be warm and it would, drop like this continuously until it kind of acclimated to room temperature. And after that, it stabled out. So it looks like this one is still dropping a little. Of course, we are taking a measurement of it, which puts it in line with the circuit. So I'll be testing this one out here shortly. But let me hook up this other one that run for about an hour and a half, or maybe a little bit longer than that. We'll take a look at that too. Just let me hook it up and we'll see what the voltage is. So looks like we started with a 9.4 volt. It's sitting at 7.47, and it looks like this is climbing. Yeah, it's climbing slowly. Okay, now let's take a look and see how long this ran. So if I tailed the log, it'll tell me 1758 is when it died. Well, wait a minute, that's 0.3. Yeah, it was right at 1758 when it died. Although it's just, open it up and take a look. And when I started it started at 6:35, and it actually ran a couple minutes before I got things set up to log this. So 6:35. looks like it started dropping about 5:56. So, basically run a little less than an hour and a half at, 38 milliamps. Just notice that my decimal places are off on this, but I will fix that in the next update of this program. So that's my findings. Took just a Duracell battery that wouldn't power anything and threw it in the charger for a few hours. I know it was in there 2-3 hours over a period of time, and I have done this test twice on this, but I had an issue with my timestamp, so I had to recharge it and do it again. So I effectively did get an hour and a half functionality out of this battery, and I never have run something like that this long, pulling 38 milliamps of current, and I'm wondering how long it would run, with a lower powered device, like maybe a tone generator or something like that. But anyway, that's what I found out. I will hook this one up and see what kind of current it draws. I couldn't find out what the rating was on it, but it does say that carbon zinc batteries has around 400 milliamp henry rating on it. So I will hook this up and see if it powers this and see how long it runs. Okay, so it did power it up. Looks like I said it would not do this before at all. Wouldn't even come on. Looks like we're getting 34 right at 34 milliamps. And this is just, like I said, a battery I found outside, and it was actually in a tape measure stud finder combination Ryobi tool thing that was laying on the side of the road. I apologize for my decimal spots, but that is 30, 32, 33 milliamps right now. So let this run for a little while, see what it does, and I'm just curious as to oh, that didn't take long. Okay, so it is dead to the world. I'll stop this test. Okay. So that thing didn't make it 5 minutes. And it's been charging for well over 2 hours, and it was showing 10 volts basically is what I was getting on it a while ago. So yeah, looks like the carbon zinc batteries definitely will not be worth anything. So may have a shot at alkaline batteries, but not the carbon zinc. And if I had some time, I'd really like to take this thing apart, because that carbon rod would be something I would like to keep. And I do some scrapping and stuff like that. I just wonder what other kind of metals in here. I know this is a tin plated jacket, or a steel, tin plated steel jacket on this, and it's got some other metal in it, but yeah. Anyway, there you have it. That's what I found out, and I want to be testing a couple of the batteries just to see if, look at the ratings on them. I got an Energizer here, and I've got some old rechargeables here that do some tests with, and figure out how long they'll last. But it's interesting. This right here on the battery boasts 2450 milliamp henries. Of course, this is a 1.3 volt battery, so it definitely probably will not push the current that you need to power other devices. So there you have it. Looks like it won't blow up, and did get some use out of this one after I charged it for a while. Maybe save somebody a little money.